Alrighty, so it says we are on 9-1 day 1 notes, which is triangles on the coordinate plane. So the I can statement, I can use the coordinate plane to analyze geometric figures. All right, so the first thing to do is the properties of geometric figures plotted on the coordinate plane, such as length. Oops. Parallel lines. Existence of right angles. Or location of midpoints. Can be described using the formulas for distance. Would help if this didn't drag. Slope and midpoint. So distance, slope, and midpoint have all been used from topic 1. So we're going to review those just a little bit, okay? Is anybody still writing this down? Okay. All right, so use the distance formula to find the lengths of the segments to classify figures. Use the slope formula to determine whether two lines or segments are parallel or perpendicular. So just as a recap for some of these, okay, do we need assigned seats? Okay, so when I'm talking, you are listening. You are not having private conversations, okay? Thank you. Okay, so in this case, in words, if we take a look, it says use the distance formula to find the lengths of segments to classify figures. So if we are looking at this, we would use the distance formula to find each length. Now look at this simplest radical form. This right here, remember, is an exact answer. Because if on a test or quiz they ask you for a decimal, they'll tell you to round, which is not exact, it's approximate. Or if they ask for an exact answer, you're dealing with a radical or a fraction of some kind, or maybe a combination of both. And now the same thing for the slope to determine if these are parallel or perpendicular, that's going to help us with the angles. All right, so in this case, using the slope formula, there would be your exact answer. So the distance formula, just recall, is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And then for slope, we're going to have y2 minus y1 over x2 minus x1. Remember, rise over run. And I'm going to give you the midpoint formula just so you have it, okay? So midpoint, remember, is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Remember, this is calculated 2 separate times for x and y. Huh? Sure. You might have to sharpen it, though. So these are the 3 formulas that are discussed today. Is anybody still writing? All right, let's talk about classifying triangles. So the first one they're talking about is an equilateral triangle. So the diagram would look like this. If I have a triangle, I have all three of those sides congruent. Some of the properties, one property is that all sides are equal length. And the second property is that all angles are congruent. In fact, they're all 60 degrees. Then we have an isosceles triangle. Someone dying? Okay. So then we have an isosceles triangle. And in this case, one property is that two sides are equal length. And the second property would be that the two base angles are congruent. Now, we do not have a specific length for that because isosceles triangles can come in many different forms. However, equilateral triangles, as long as they're all equal, it doesn't matter how big you make those sides, those angles will always be 60 degrees. Then we have a scalene triangle. And what that means is that all three sides have different lengths. So all three sides have different lengths, which means that all those angles are probably not going to be equal either. Okay, they're all going to be different. Bless you. Questions? Anybody still writing? All right, let's go ahead to the back side. All right, so example one, it says triangle XYZ is equilateral. Is it equilateral, isosceles, or scalene? So what we're going to do is we are going to calculate the sides of these and see what we have going on, okay? So let's first take a look at YZ, which I'll complete in orange. So for YZ, here's Y, here's Z. I'm going to put that into my distance formula. So YZ is going to equal the square root of 8 minus 5 squared plus 6 minus 8 squared. This leaves us with 3 squared plus negative 2 squared. Which gives us 9 plus 4, which ends up being the square root of 13. So we have the first side all squared away. And I'm going to do this 2 more times. I'm going to do it for ZX. So here's Z, here's X. I'm going to represent that in purple. So ZX is going to equal the square root of 8 minus 1 squared plus 6 minus 2 squared which gives us 7 squared plus 4 squared. Which ends up being 49 plus 16. Oops. Which ends up equaling the square root of 65. So here is that one. How are we doing so far on this? Does everybody see what I'm doing? Are there any questions before I move on? All right, so now I'm going to do this one more time. Now, it's real tempting to stop there. Don't. Okay, you're going to have to analyze each side of these triangles. So now we're talking about x, y, which I'll represent in green. So we're going to have x, y equals the square root of 5 minus 1 squared plus 8 minus 2 squared. This equals 4 squared plus 6 squared. Which gives me 16 plus 36. And I'm left with the square root of 52. Now, based off this information that I just found, what type of triangle do I have here? Do I have an equilateral, an isosceles, or a scalene? What do you got? It's scalene. All sides are different. So all sides are different. So we have a scalene triangle. All right, I want you guys to give this a shot. Look at the next one, the you try it. I'm going to call 3 people up to show me their distance formula. Okay, so your best bet here, just to start out, is to draw a picture. Okay, so they're giving you the 3 sides. So you have T, L, A, and you can just put the points that you have for them. So this will be -5, 6. L would be 5, 6. And A would be 0, -6. I want you guys to find the distance of each of these sides. All right, and then we'll talk about what kind of triangle it is. Go ahead. Oh, and just so you have it, remember distance is equal to x2 minus x1 squared plus y2 minus y1 squared. What's up, Louise? You all right? Okay. All right. How we doing? Who's still working on this one? If you are, just raise your hand. Okay. Just double checking. All right. How we doing? I see some people still writing, so I'll give it another minute. Does someone have the length of TL? Can they go up and show me? Who's still working on it? I just need a show of hands. If you are, it's fine. I just want to make sure. Okay. All right. Volunteers, or do I have to go to the Delta Math? Who's got TL? I just want to see that you guys understand the distance formula, okay? Doesn't matter if you got it right or wrong. I just want to talk about it. Okay? Any volunteers for TL? Let's see. Anybody for TL? Broden, you have TL. Yeah, just write out like how you set up the distance formula and then just give us your answer. Okay? You don't have to reinvent the wheel here. I just want to make sure we're setting it up correctly. All right, LA. Layla C. It's okay. I just want to see your setup. I don't know. I mean, I can tell you I'm using Delta Math. I think some people can see it. Right? She got a length of 0. Okay. You gotta remember one's negative and one's positive. So if you're subtracting them, so one has to be negative there. Like it should be like -10 and -12. Oh no, wait, no. The second part. I'm talking about the first part. First part should be like -10 squared. It's okay. We'll talk about it. All right. So she's got LA. Connor, you've got AT. Let me see it. Let me see it. You probably overcomplicated it. Let's see. Okay, so you did 0 minus 5. Okay. Oh, you used the two incorrect points. So it's -6 minus, or it's a 6 minus a -6 on the second one. Are you seeing it now? Good, 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 good. That's all I want to do, right? Because you're gonna have to do this on your test and quiz. So I just want to see how we're doing with that setup. What'd you get for AT? Square root of 119. Okay, let's talk about these a little bit. All right, so you guys have a pretty decent understanding of what's happening, but I just want to go over that one more time. Okay. So, silly mistakes always get made, but we got to make sure that we solidify these before an assessment, right? All right, so let's take a look at TL. So TL, so here is point T, here is point L. So I'm going to have here, okay, if I do this as X2, Y2, and this is my X1, Y1, okay? So I'm going to have here -5 minus 5 quantity squared plus, in this case, 6 minus 6 quantity squared. So this part is correct. This is 0. There's nothing to do there. But we still have this, which is supposed to be the square root of -10 squared, which leaves me with the square root of 100, which leaves me with a total of 10. So you missed a negative. It wasn't a big deal, right? But this is why we talk. So the first one should have been 10. Let's take a look at LA, okay? LA, in this case, we're using this point and this point. So again, I'm just going to keep this x1, y1. I'm going to make this x2, y2. So again, applying that distance formula, I'm going to have here 0 minus 5 squared plus negative 6 minus a 6 squared. So this becomes negative 5 squared plus negative 12 squared. Which leaves me with the square root of 25 plus 144, which is the square root of 169, which is a perfect square, leaving me with a total of 13. How are we doing so far? Is this making a little more sense? I do have to clear the screen, so is anybody writing this down? Okay. I'm just going to I'm going to clear the screen, and then I'll put these numbers back. Well, actually, I'm not going to close the screen. I'm going to just erase this red one right here, and then I'll just use that space. All right, so for the next one, now what I'm using is AT. So here's A, here's T. So again, I got to define one of these as 0.1. So I'm going to state this is x1, y1, just for this last part, okay? So this is going to be the square root of 0 minus a negative 5, quantity squared, plus negative 6 minus 6, quantity squared. So again, this is looking a lot like this one, right? So do I have the same length for a side? Yes or no? This looks very similar to this, right? We're going to have, again, like 25 plus 144. So is LA and AT going to be the same? Yeah. So this is 13 as well, which means we have LA is congruent to TA. So what kind of triangle do we have? We have an isosceles triangle, yep. And then they're asking, what is the perimeter? All we need to do there is 10 plus 13 plus 13, which leaves us with 36. Questions on that? All right, let's take a look at example 2. Now, we've got some big numbers here, but the first thing we're going to do is this. We're going to find the distances of each of these. All right, so again, nothing's really changing. Just for context, I am going to draw a triangle. Again, we call it HAM. And it looks like H is 9, negative 2. A is 4, 6. And M is 2016. I'm going to scoot that over a little bit. So again, it doesn't matter what you decide is length 1 or length 2 or x1 or x2, okay? It just be consistent when you do it. Can someone erase the board real quick for me? Anybody, please? Oh, thank you. So again, it doesn't matter what you choose. Remember, this is our distance formula. I'm just going to put that in green. So our distance formula, remember, is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so nothing's changing with the formula. Now this first one I'm going to perform in orange. So HA. I have it where looks like this is 0.2 And this is my 0.1. So this is going to be the square root of 9 minus 4 squared plus negative 2 minus 6 squared. So this is 5, this is 8. That's going to leave me with 25 plus 64. So here I have the square root of 84. So there it is. Square root of 84 is my first length. AM, I'm going to be doing, again, the same thing. Here's A, here's M. So in my notes, I defined this as 0.2. So this is x2, y2, and this is x1, y1. So here I'm going to have, let's see, it looks like 4 minus 20, quantity squared, plus 6 minus 16, quantity squared. Now 4 minus 20 is 16, or negative 16. I square that, that leaves me with 256. And I'm going to add to this. Looks like this will be 10, so this will be 100. So this leaves me with the square root of 356. So we have 356 for that one. And now we're going to do MH. All right, so in this case, here is M, here is H. I have, looks like, this is my second point now. This is my first point. So I'm going to have here 20 minus 9 squared plus 16 minus a negative 2 squared. Now, one thing you gotta keep in mind is that this is a negative negative, both those become positive. So 20 minus 9 leaves me with 11, which ends up, and 11 squared leaves me with 121. This ends up being 18. So 18 squared is 324. Add those up, I get the square root of 445. So what kind of triangle is this? Acute? Is it right? Oh no, I'm sorry. Is it equilateral, isosceles, or scalene? Scalene. Okay, so we got that part. So that's pretty easy. That was pretty easy. Time consuming, but not too bad, right? All right, let's talk about, is HAM a right triangle? So we're going to tap into some of our skills from 8. All right, from topic 8. So in this case, what you can use is you can use the converse of the Pythagorean theorem. Okay, so what we're going to set this up as is a squared plus b squared. You know, we don't really know what's going on. Is it equal to, is it less than, greater than? We don't know, but we're going to set that up with c squared. So I'm going to take my lengths right here, and remember, the two smaller lengths combined need to be equal to the larger length, okay? So in this case, we're going to have 80, square root of 89 squared plus the square root of 356 squared. And we're just going to see if it equals 445, the square root of 445 squared. This becomes 89 plus 356. What is 89 plus 356? Go. 445. So 445, that equals 445. So yes, this is a right triangle. Okay. Questions on that? I know it's a little lengthy today, but all you need to remember is appropriately setting up distance formula and that converse. Homework is on Delta Math tonight. You guys can get going on that with the remainder of the time, okay? Any questions, please see me. Those of you working at home, have a great day.